Assalamu alaikum. Hello everyone. I am Mahfuzur Rahman, lecturer, Department of ICT. I hope you all are fine and you already updated with our regular study plan, what you have make yourself in WhatsApp group. Please maintain a regular study and please follow our study plan.
So, what you will learn: signed number, ones complement, twos complement, importance of formation of twos complement, difference between ones and twos complement. What is signed number? In general, we represent the positive unsigned numbers without any sign indication and negative numbers with minus, that means negative sign, before them. But these are not applicable for computing in digital systems like computers or any other device, logical devices or any other devices. As the data is represented in binary number system, so to represent the sign, a special notation is required. This is called signed number. When we represent a number with a sign like positive or negative sign including. So after that we have signed bit. So as you already have the knowledge about signed number, now we'll learn what is signed bit. It's a bit much important thing to do ones or twos complement at your exam or for regular practice. Sign bit. An extra bit is added before an actual value to represent the signed number in the binary method. This extra bit is called sign bit. If the bit is 0, then number is positive, and if the bit is 1, the number is assumed to be negative. It's a very important point. You must have to keep in your mind. If the signed bit is 0, the number is positive, and if the bit is 1, the number is assumed to be negative. This is called the signed bit. It will define the two status of a bit. It's negative and a positive one. Okay. So this bit is called sign bit. That's it stays at the left corner to keep the sign and number included with sign is called signed number. So this bit stays at your left at your corner to keep the sign of a number. Either the number is going to be negative or positive. Okay. So next, what we have to learn, what is complement, we have to know. Complements are used in digital computers in order to simplify the subtraction operation and for the logical manipulation. That means in digital computers, if you want to simplify the subtraction operation, because the computer only can perform a single operation, is addition. So in our regular life, we have subtraction, we have multiplication, we have division also. So all those forms are done by a computer device with only a single operation, with addition operation only. So now what are the next? We have binary system complement. As the binary system has base r equals to 2, we know because binary have only 2 digits. That means 0 and 1. That's why binary number system has the base r equals to 2. So the two types of complement for the binary number systems, that's why number 1 is 2's complement and number 2 is 1's complement. In binary number system, it's another important thing you must have to remember. In binary number system, you have two types of complement, 1's complement and 2's complement. Why? Because binary number system has the base r equals to 2. Now, the another basic thing you must have to learn, what is 1's complement. The 1's complement of a number is founded by changing all the 1's to 0's and all the 0's to 1's. This is called taking the complement or 1's complement. This means you just have to change the vice versa. If you find 1 at your binary number, you have to change it with 0. If you found 0 at your binary number, you just have to change it to 1. This is the thing what you have to do in 1's complement. Example of 1's complement is as follows. I have an attached picture to make you understandable more. So this one is the given number. You see 1 0 1 0 1. The 1's complement will be the simple thing. 1 will be complemented by 0. 0 will be complemented by 1. Again 1 will be complemented with 0 and 0 will be complemented by 1. Similar, 1 will be complemented by 0. These are the simple process to make a complement of an binary number. Just simply change the values 1s to 0s and 0s to 1s. Next, what we have, 2's complement. Now I'm giving you some basic ideas about 2's complement. The 2's complement of a binary number is obtained by adding 1 to the least significant bit LSB and 1's complement of the number. 1's complement and 2's complement plus 1. Just simply you have to do this simple step. Just when you are going to do the 2's complement, first you have to perform the operation of 1's complement. Then you have to add just a single number 1 in the LSB of an 1's complement of a number. I am giving you an example now to make you clear. You see the previous slide's example, I already taken it here. The given number was 1 0 1 0 1. Now I am just making this number for 1's complement like 0 1. That means this 1 will be translated to 0, this 0 will be translated to 1, and this 1 will be translated to complemented to 0. So now I'm just simply add a 1 at the LSB, that means least significant bit, then I will get the answer.
Question, please do it at our WhatsApp group,
Okay.
and you can feel free to comment at my videos comment section. Again
You
and
see
again I want to tell you
the
a
answer
simple
now?
thing. Please stay at
Yeah,
home for
right.
your
Just you
and
have to
your
perform a binary
family safety.
addition
Allah
with your
Hafiz,
given
this is Mahfuzur Rahman
number.
from Milestone
After
College ICT
performing
department.
1's complement, you just have to add a single 1. Then we will find the value of a 2's complement. You see, it's a very simple step you have to follow. Just you have to change the value to 1's to 0, 0's to 1. Then you have to add 1 with your 1's complemented value. Then you will get the final result of 2's complement. Okay. Addition in 2's complement form. How we perform addition in 2's complement form? The given signed number had to be represented in 2's complemented form. Then add the binary number of the obtained value. If the extra carry bit is present in the sum, that is if the sum is greater than 8 bit, in case of 8-bit register, then the leftmost bit is called carry bit. That means it's an extra bit or overflow bit. In other words, we can say, if it is going to be an 8-bit register, you must have to keep in your mind, you can put 8-bit or 8 binary number in a single register. You can't put it further here. So the extra bit, what you will find, the 9th bit, this one will be counted as carry bit. So it should be omitted, because you have 8-bit register, you have 8 slots of binary bit you can take place on your register. The number thus obtained will be the sum of the given number. Then this is the process how we gonna do the addition of 2's complement. Now I am giving you some example of subtraction in 2's complement form. How we subtract. The number which will be subtracted should be changed in the sign and then has to be represented in 2's complemented form. Then the second signed number has to be represented in 2's complemented form. After that, then add the obtained binary value. Addition also has to be done in subtraction mode. After that, if the extra carry bit is represented in the sum, that is if the sum is greater than 8 bits, In case of 8-bit register, then the leftmost bit will be the carry bit. So it should be omitted again, because in 8-bit register you have only 8 bits of memory slot you have in your hand to keep the binary numbers in the place. Thus the number obtained will be the difference between the given numbers. So this is the process how we're going to subtract in 2's complement form. Now I am giving you the importance of formation of 2's complement, basically why we use 2's complement in our logical circuits or in our computer device or any other devices, why we use 2's complement. Subtraction function can be performed by addition. Same circuit is used for addition and subtraction to combine of 2's complement. 2's complementary system is used in modern computer. Simple logic circuit can be made using this formation of 2's complement. Circuit will be less expensive in the price and it also works fast. Circuit intensity and its complexity becomes less than before. Basically, this is the benefit what we get from a 2's complement. The circuit's price is less expensive than before and it works super fast than ever we have. And the circuit intensity and complexity become less than before. What we have a lot of complexity in developing a complexity in logic circuits. Now I'm showing you the difference between 1's and 2's complement. What are the basic difference between these two? 1's complement, it can be easily obtained using inverter. 2's complement, it has to be arrived by at the first obtaining, then 1's complement, then adding 1 into it. Basically it's dependent with 1's complement, because first you have to do the 1's complement, then you have to add 1 to do that. Then 1's complement, it requires 2 operation. Only 1 arithmetic operation is required in 2's complement. Basically first you have to convert the binary phase, then you have to just complement it. Basically you have 2 operations in 1's complement side, and in 2's complement side you have only 1 operation, just you have to add 1 in 1's complement mode. It's often used in logical manipulation for inversion operation, and 2's complement, it is only used for arithmetic applications only. I hope you already got some valuable knowledge at signed bit, signed number and 1's complement, 2's complement from very basic, and I'm showing you a difference between 1's complement and 2's complement. To comment at my videos comment section. Again and again I want to tell you a simple thing: please stay at home for your and your family safety. Allah Hafiz. This is Mahfuzur Rahman from Milestone College ICT department.